Hi, welcome to polymers. This should be the last of the videos in carbon chemistry, and it should pretty much tell you everything you need to know about polymers. Just a word of warning, at the end of the year you'll be looking at lots of past papers, hopefully, when you're studying for the end of the year paper, and you'll find some questions that go into a bit more detail about polymers. That's just because in previous years we used to know a little bit more, but this video should pretty much sum up everything you need to know about polymers, hopefully. Okay, let's have a look at it. What are polymers? Well, polymers, effectively we're talking about plastics here. What they are long chain molecules, carbon chains, or giant molecules. And so under the right conditions, it's the alkenes, and they're very important for the production of polymers. The alkene molecules can join up and sort of keep adding to each other and form long chains. And chemical engineers can manipulate those chains to form all the different types of plastics that we have, from the soft bendy ones to the brittle ones to the heat resistant ones to all sorts of things, ones you wear as clothes, all sorts of different plastics. But we're just going to learn the nuts and bolts about that. And so when we're talking about giant molecules, we're talking about hundreds and hundreds or even thousands of carbons joined together. And so we're departing from our very simple ideas of what molecules are. Now these giant molecules are called polymers. Polymer, the poly meaning multi, and we'll get where the mers come from in a sec. So the small molecules that are added together, they have their own name, and they're called monomers, or derived from one part. And these monomers go to make all the pieces in the chain. So a monomer is like one link in a chain, and when you put all the links together, all the monomers, you get the polymer. Okay? And the process by which these giant molecules or polymers form is called addition polymerization. Remember we had addition reactions and substitution reactions? Well, this is another use of the word addition. It's addition polymerization, so try not to confuse them. A set of polymers produced in this way are classified as addition polymers. Addition polymers, so here we have ethene, commonly known as ethanol. No, what is it? Ethylene. But this is ethene. There's our double bond between two carbons, and there's another one, and these guys are our monomers. So think of these as the individual links, and they haven't been linked together, so they don't form a chain yet, and in the presence of a catalyst they will start to bond together. And how they do that is that the double bond disappears, and one of the covalent bonds breaks. That frees up two electrons that move around, and hydrogens come. The two electrons then form this bond here. So effectively, if we were to draw something that tried to represent this, have we got our pen yet? Waiting for it. Here it comes. So we've got a pair of electrons here. Okay, let's ignore the other pair of electrons because they're going to stay as a covalent bond. One of these electrons swing around here to form there, and this electron swings around here to be there. Now if simultaneously we're also got a bonding pair of electrons there, and that bond breaks, and the electron goes to be there, and the electron goes to be there, that means that these two electrons can form a covalent bond, and similarly over here. And so that's where, by breaking one of the double bonds, one bond in the double bond, probably more precise, we can get this chain. So if we're looking at this diagram, that one is a new bond, that one is a new bond, that one is a new bond, and this one. Now the dots just mean that goes on ad infinitum, and so instead of drawing the entire molecule, we just draw a section of it and go ... Okay, so that happens in the presence of a catalyst, and we don't have to have just simple Alkenes, we can have more complex ones. Now this is a benzene group, we don't need to know about it, and this little monomer is called styrene, so you can probably guess what the polymer is going to be called. It's polystyrene, because this one here is polyethylene, polyethylene or polyethylene. Getting my tongue a little bit tight, but you can see here, if you recognize this, they've drawn it so that that molecule, let's just get this pen back. Where are the monomers on this diagram? The monomers are there, there, and there, and the double bonds disappeared to make that one, and that one, and that one. Okay? So it gets a bit confusing, but once you get your head around it, these diagrams do make sense. So let's move on. So here we have vinyl chloride. So it's a ethene, but it's got a chlorine on it. So that could be a chloroethene if it was its full name. These are the monomers, and you've got plus ... and so it's going to form this. And if we looked at it, and if we tried to recognize our monomers, we would say that there's one monomer, there's another monomer, and there's another monomer. It's no longer a monomer because they're now joined. So we've lost our double bond. One of those bonds in the double bond's broken and formed a new carbon-carbon bond. Alright, let's move on. And so this is a schematic diagram. So I included this one because it's got lots of colours in it, and the colour is coordinated. So they're trying to show here that one of the bonds breaks, the electrons swing round and form a new bond, and they've put a box around it and introduced a new term. It's called a repeating unit. And so basically the repeating unit is the representation of the monomer. But the common way of drawing it is to put it in square brackets like this with an n, because n is a large integer basically. And so this is the repeating or reoccurring unit, and you can see here that that could have been drawn around that lot there, or this lot here, anywhere. So make sure you understand that diagram and what's happening. So using repeating units to represent addition polymers, again, here's our monomer, there's our reoccurring unit diagram. Here's a different monomer. This one's got a branch on it, so effectively it's butene, I think, it's a chain of 3, and notice that this guy is located up here. A lot of people want to draw it as part of the chain, but it doesn't take part of the chain. The chain only occurs between the carbons that have the double bond, and so any other carbon is just a little branch off the reoccurring unit. Okay, that confuses people quite a lot, that one. So there's our monomers, there's our repeating units, and let's just do a sample problem. So here's our monomer. It's actually exactly the same as the last one, just swapped around, and there's our monomer. And what's our catalyst going to, with our catalyst, what's our polymer going to look like? Here it is here, and they've drawn this one down here. Now a lot of students want to draw this, which is wrong. They go, aha, they've got this, so we'll go carbon, 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 hang on, carbon, and then they just go, yeah, all the carbons are joined up, and then dot dot dot, and dot dot dot, dot dot, they go dot dot, we've got to have hydrogens. Okay, that's wrong. What you've got to do is make sure that you represent that as occurring off the branch. So this is wrong, and make sure you put in anything that's off the double bond, just gets reoccurred every second one. Let's move on. Okay, so you can do these revision questions now, and you should be able to do those. And we're in chapter 9 And so you should be able to do these questions in chapter 9, and I'm going to put some links on the OneNote to some videos that you can watch just to make sure that you understand everything. That should be enough.